Not long ago, on April 20th, the next-generation manned spacecraft Starship, created by Elon Musk's rocket company SpaceX, underwent a test. This massive rocket, reaching about 120 meters in height, is the largest in human history and is designed to carry up to 100 people through space. If successful, it is expected to usher in a new era of commercial space tourism. However, due to its size, equivalent to a 40-story apartment building, launching the rocket is challenging. And the development is even more difficult because both stages need to be 100% reusable. As expected, the test did not succeed, and the event became a hot topic. Interestingly, Starship employees cheered as the spacecraft exploded. Now, I will explain why the employees cheered at the sight of the failed rocket. Many media outlets are focusing on the explosion of Starship, but in fact, the spacecraft has already experienced numerous explosions and failures during the development of the two-stage Starship spacecraft, only achieving success about a year ago. If you look at the history of rocket development in the United States and the Soviet Union, failures were almost expected in the early days. The R-7 Semyorka, which became the basis for the Soviet Union's Soyuz rocket, had 9 launch failures initially, but no one calls the Soyuz rocket a failure. The Soyuz now holds the world's largest rocket launch record, with nearly 2,000 launches, and is considered the world's safest rocket with a launch failure rate of less than 0.1%. Similarly, the main objectives of this Starship launch were to test whether the rocket's 33 booster engines could be controlled and whether it could pass through Max Q, the point at which the rocket experiences the most significant pressure. Max Q is the most common point of failure if a rocket's design is not perfect. Since it is the most frequent point of destruction during a rocket launch, it is used as a criterion to evaluate whether a rocket can withstand maximum stress. The max Q for Starship is about 1 minute and 30 seconds after launch, and during this test, the rocket successfully passed through max Q and flew steadily for nearly 4 minutes, before reaching the point where the first and second stages were to separate. This is why Starship employees cheered. In this test, the Starship reached the stage separation point, but for some reason, the stages did not separate, and with all the fuel exhausted, the self-destruct system, also known as the self-destruct mechanism, caused the explosion in mid-air. Large rockets like Starship have a built-in self-destruct system, because they pose a risk of falling back to Earth and exploding if crucial do not occur, potentially causing casualties. However, many media outlets have misrepresented the self-destruct system's explosion as a result of a rocket design flaw. While the exact cause of the stage separation failure has not been identified, the enormous pressure from passing through Max Q could have damaged one of the components needed for stage separation. SpaceX anticipated this issue since it was the first time it was being tested. Fortunately, since the failure was not due to an inability to pass through Max Q or a rocket engine control failure, there is hope for improvement. In the First World War, when airplanes first appeared, there were overwhelmingly more crashes due to malfunctions than crashes due to combat. At that time, a pilot even commented that using airplanes as a means of transporting people was a crazy idea, as the probability of a malfunction was higher than that of not having one. However, in just 100 years, airplanes have become the safest mode of transportation among all human-made vehicles. This is because they have gone through countless tests, continually improving and overcoming flaws. In contrast, rockets have been used far less frequently than airplanes. To date, humans have built millions of jet engines for airplanes, and thousands of planes take off daily, accumulating a massive number of tests. On the other hand, even the most tested Soyuz rocket has been launched less than 2,000 times. However, SpaceX's Starship uses 33 booster engines, allowing for a significant accumulation of tests with each launch. Thanks to its reusability and low launch costs, a vast number of rocket engine tests are expected to be conducted. As a result, Starship's Raptor engine can be mass-produced, and with continuous testing over the years, it is expected to achieve a higher launch success rate than Soyuz. The mass production and 100% recyclability of Starship will help reduce rocket launch costs, making commercial space travel a reality. But is there a need for humans to go to Mars? Some people argue that instead of investing in space development, we should focus on protecting the Earth's environment. Of course, if investing in space development accelerates global warming and puts human lives at risk, that's a valid point. However, the cost of rocket development is minuscule compared to the funds needed to combat climate change. The International Energy Agency estimates that at least $2 trillion per year is needed to prevent the critical point of global warming from being crossed. In reality, nearly $1 trillion is already being spent annually on direct and indirect costs for climate change prevention. This amount is at least 100 times greater than the annual $10 billion invested in space development. Therefore, even if space development costs were reduced to zero, the outcome would not change. The money needed to combat climate change is increasing much faster than space development investments, making up less than 1% of the total required funds. It's like advising someone who saves $1,000 monthly for a house to cut down on 1 or 2 cups of coffee to save $1,010 instead. In fact, technologies derived from research for space development can help fight climate change. A portion of space development costs can be considered necessary for achieving carbon neutrality. The goal of humans going to Mars is not only for scientific reasons, but also because the technology developed for operating a space base on Mars can help save Earth. For example, technology that converts carbon dioxide into oxygen using electrical energy can be more effective and affordable than planting trees once nuclear fusion is achieved and electricity costs are reduced. Low-cost space launches can be used for space-based solar power and installing solar shades in space to reduce Earth's temperature. Although SpaceX didn't achieve orbit this time, their initial goal was to complete Starship by 2024. Hopefully, they can identify the cause, make improvements, and succeed in the next attempt. That's all for today's journey. I'll be back with more exciting topics next time. Please subscribe, like, and comment, as it helps the channel a lot. Until we meet again, don't lose your curiosity about space.